Hi. There were several of you who wanted the exercises solved for the finding patterns section for grep and for find. So I will go over them fairly quickly here. So if you went down on the page for finding patterns until you got to the exercises, there were a few exercises here, and there is actually a solution that you can click to reveal here. When first, try finding the pattern string in new file.txt. And the directory you should look in is if you have downloaded the tarball that was on the preparations on the first page, and then unpacked it as also described there. You get a directory exercises, and I have this here on tetralit, and I will go into the directory patterns. And in there, there is a number of files that are suitable for this exercise here. So the first one is try finding the pattern string in new file.txt. And in order to do that, I am just going to use a grep and then string and then new file. And then I will see that, yes, there is indeed such a string called string. And it has marked it here because I have a color on in my terminal. Then search for instances of the word contains in field.txt and count them. Field.txt is this one here. And in order to count it, you are also using a pipe that we looked at in the previous section. So first I am grepping for contains in this field.txt. Let's see what happens when I do that. So it tells me the line that it is in. And I also wanted to count it. And I'm doing that by using a pipe. And then I'm using word count. And I say I just want to know the number of lines. And we expect a 1 here, and that is what we get. Now, there is a possibility that we don't know how string is written or how contains is written, if it's with the capital letters or not. So, I mean, you could add -i if you actually want all instances of the string contains. In this case, it does not matter because there's only this one instance in lowercase, but if you add -i, it also adds those that are written with some or all letters in caps. So, okay, so this was this one here. And then I will go and look at search for the lines with instances of word, this word in field.txt and output them to field.out. So I will grep again, and I am asked again, I will add -i because I want to be sure that I get all of them. And so I say word, and I say field because I'm looking in field. And then I'm going to redirect the output to the field, to the file.out, like this here. And now we will have a file called file.out. So we do ls. And there you can see that the file.out is here, and we can use cat, as we saw earlier today, to see what is inside of this file. And it has indeed the line that we found before. So what instead, if we want to search for lines with a specific string in a file, and in this case, new file text, and we want to append it to the file we got before. we can do that as well. So again, we grep, and I'm looking for it, whether it's uppercase or lowercase, and I'm looking for string. If it is more than one word, you need to put these apostrophes around it. And I'm looking for it in new file.txt. And then I'm appending it. And appending something I do with these double greater than. And I'm using the file.out. So let's see what is now in file.out. It grabbed all the lines that contain the word, the string, and appended those to the file.out. And the string in new file.txt, we already knew from here earlier that it was these ones, and you can see it did indeed find those and appended them to this file here. So that works as we had expected. Okay, so let's go and look at the find, because there were also some exercises for find. And here there's two exercises. There's one for find the file feel4.txt in the directory you're standing in and below. And in order to do that, we will use find. And we are looking in this directory and below, and we are looking for files of the type. We are looking for files, so we're looking at type F for files, and it has to have the name feel4.txt. So we say feel4.txt, and in this case, it's best to put these exclamation marks around it, or whatever they're called in English. Quotation marks in English. So we use those. And as expected, it finds this file feel4.txt in the directory dir1 that we can see is below the current dir, which is the dot. And there below is feel4.txt. So I will just do ls dir1, and then you can see it does indeed have a file called feel4.txt. So what is the next exercise? It is find the file, myfile0.txt, in expressions patterns while standing in exercises script. We should stand in script, so I'm going to go up and into script. And then I'm going to go and say find in, I go up and down into patterns. So I'm looking in the directory patterns. I again say the type has to be file, and it has to have the name myfile0.txt, as you can see here. So this one. And then I'm checking, and I am told that yes, indeed, there is such a file. So it also works to look for it this way. Okay, those were the exercises. I will also very briefly cover the advanced materials section on regular expression, which we did not cover because of time constraints. So regular expressions are a type of patterns used when you are working with text. Because of convenience, regular expressions are commonly used in programming languages, but the syntax can vary between languages. And you can use these regular expressions with commands like grep and find, and also many of the other commands that you already have seen, and others, for instance, that you're using in scripting. So note that if your regular expression does not do as you expect, you may need to use either single quotation marks around the sentence, or you may also have to use a backslash on every single special characters. And that could be, for instance, if you were looking for a backslash, which is a special character, you would have to escape it by putting an extra one of those. So 2 of those in if you're actually looking for a backslash, for instance. There are online tools that allow you to test regular expressions. For instance, this one here at this address, regex101.com. And it has different languages supported. And if you have not too complex regular expression, most of those that you can find on this page here for different languages, they should actually work with grep and find. And as always, just like when you're removing files and use wildcards, it's good to do dry runs, for instance, with ls, before you run commands with regular expression if you are doing something that modify or delete files. So let's look at some common examples of regular expressions. A dot that matches any single character, and this is the same as the question mark was in standard wildcard expressions. And this backslash is used as an escape character for a subsequent special character. So as I said, if you, for instance, look for a backslash or $, hat, or something else, then you need to put this backslash, the escape character, before it to tell the system that you are looking for the special character. So instead of just having it represent part of the regular expression. And then dot star is matching any string equivalent to star or asterisk in standard wildcards. And if you just have an asterisk, the preceding items is matched 0 or more time. So if, for instance, you wrote an N and an asterisk, it matches N, NN, 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 and so on, but not NA or NB or any other character after N. A hat means the beginning of a line. So if you say hat A, it means that you want to find a line that is starting with an A. A $sign means the end of a line. So a $sign means find a line that ends with an A. You can also use ranges, just like we saw previously with the wildcards. And it's also these hard parentheses. And it is an OR relationship, is worth mentioning. You only need one to match. Then there is this pipe that is also used for this wildcard, is also used as logical OR relationship between wildcards. So you can search for one thing or the other, or both. You may need to add a quotation mark before the command to avoid the shell thinking you want a pipe, because it's also used for this, and it's probably the more common use of it, but it's also used as an OR. And then if in hard parentheses you put a hat, then it is the same as a exclamation mark in hard parentheses in standard wildcards. So it's a logical not, and it matches anything that's not listed within the square brackets. So if you said hard parentheses hat and then a 4, then you would match anything that doesn't have 4. So here is an advanced example, and that searches for the file my file. In lines start for in files my file. Here it cats, so it outputs to screen the content of my file. Then you pipe it to this command here, and this command here, it greps or searches for lines starting with an S and ending with an N, and in between could be anything. And it prints them to the standard output. Of course, as usual, there's this $sign here. It just represents the prompt. Leave it alone if you copy it. So you could copy this here and place it here, and it's not going to give output because there's no file named just my file here. Let's go into patterns. I don't think there's one that's just my file, but I guess we could add a star. And then it doesn't match anything because we also have dot text. And we probably actually need this here instead. And then it tells you there is no such file or directory, because when I put the exclamation marks around it, it looks for this exactly. So if I instead do like this, then it would look for a file that's called my file exclamation mark. But what happens then if I pick a file that actually exists? And let's see, we have, for instance, my file 0. And we can grep in that. And as you can see, there was no line starting with an S and ending with an N in that. But what we could do is that we create such a file, or we add to my file 0.txt. This is just a file I created with touch, so it doesn't have content. But now we will have a line that starts with an N. Not just one line. And then it needs to end with an, it needed to start with an S. So this is not just one line. Well, it is, and it ends in N. So now you have a line that starts with S and ends in N. And it didn't because I forgot this was nano and not VI. Yes, I want to save it. And then let's grep for it now. And now there is indeed such a line. And you can see it finds it. So this actually works. It looks for a line here. And to show that it actually only looked for that line, this is another line and yet another. Hello. Now it has text. So let's exit. And again, I run this here and I get the same output because it only zeroes in on this one line that starts with an S and ends with an N. So the key points were already covered in this other recording that we made earlier. Okay, I am going to stop this.